Section 2 is all about algebraic expressions. The first thing we're going to do is we're going to evaluate algebraic expressions. So it's important to know the terms so that when they say fill in the variable, you know what they mean. A variable is a symbol. In algebra, it's usually a letter. When you get into calculus, it's Greek letters. They get even more fun. That represents one or more numbers. One or more numbers. It's a group of numbers, which is why it's called a variable. It can vary depending on what you plug in for it, right? Algebraic expression is a variable or variable expression. It contains one or more variables, so it can just be expressions, by the way, are not equals. Okay, expressions are literally that. They just are an expression. They don't have an equal sign, so you are not solving for the variable in an expression. You are either simplifying or you are plugging in the variable. All right, equations is where you actually solve for the variable. But if there is no equal sign, don't try to solve. It's impossible to do because you have variables that are undefined. Evaluating an expression is when you plug in something for the variable and then you solve for what the answer would be when all the variables are plugged in. You'll see evaluating a lot in like chemistry and your sciences, right? Physics. You'll have variable expressions and they want you to specifically solve for temperature. And you have all the other variables. So they want you to plug everything in and evaluate what the temperature would be, right? And so evaluating expressions, you'll see it in other fields besides math. Math is just the number crunching of it here in this particular situation. So they've given us example 1. Evaluate a minus 2b plus ab for a equals 3 and b equals -1. They've given us an expression. They've given us what the variables are. We are literally just going to plug it in and solve. So a is 3. So instead of a, we're going to write a 3. Minus 2 times b. B is -1. So we're going to plug in a -1. Plus a times b, 3 times -1. Now, once we've done this, we are going to use order of operations. That's what we do, right? So if positives and negatives bother you, you may want to pay attention here to what happens. We have 3 minus, and then this right here, 2 times -1. What is 2 times -1? -2. So I'm putting that in parentheses. Why do you think I'm doing that? So I don't confuse those negatives right there, right? Plus, and then 3 times -1 is -3. All right? And so we have subtracting a negative, so that's adding the opposite, right? So we have 3 plus 2 plus -3. So now we have all addition, which means 1 order doesn't matter because it's all addition. 2, we just add them up, right? We don't have any of our order of operations to worry about. So 3 plus 2 is 5, minus 3 is 2, and that is our answer. Pretty straightforward. All right, first one. Should have plugged in 4 plus -2 divided by 4. What's my first step here?
-2 by 4.
Yeah, which we're actually going to get a fraction there. So what do we get? 4 plus what?
-1/2.
Yep, -1/2. All right, and if you put it in terms of fractions, you would have gotten 8 halves minus 1/2, which is 7 halves. If you did it in whole numbers, you would have gotten 3 1/2. Same thing. Either one is acceptable. All right. What about this one? We have order of operations, so we're going to do 3 and 4. 4 and -2 plus 4 minus, should be a -2 there, right? Negative. All right. So multiplication first. You could have multiplied the -4 and -2 and made that +8, whichever you prefer. It's the same thing. Plus 4 minus a -2. So we have two things we're going to change here. These are both going to be adding the opposite. So now we have all addition, right? We have 12 plus 8, which is 20, plus 4, 24, plus 2, which is 26. And there's your answer. All right. Order of operations on the last one. We're going to do this first because it's left to right. 4 plus 8 divided by negative 2. And then this is multiplication. Minus 2, negative 2, right? We're going to go in order. So 4 plus 8 divided by negative 2 is what? Negative 4 minus 2 times negative 2 is negative 4, right? Lots of 4s going on. 4, basically minus 4 is 0, plus a positive 4 is 4. Example 2 is evaluating with an exponent. Now, I will say the biggest issue with exponents is negatives, unfortunately. There is a difference between this and this, all right? It'd be helpful if I drew it a little bit. There we go, and that, okay? This top one, you are going to do the exponent first, and then you're going to apply the negative on the outside. Think of it as negative 1 times x squared, okay? For this one, you're going to apply the negative and then square it. It makes a difference, okay? Makes a difference. If I plug in a 3 here, right? 3 squared is 9, and then I make it negative. This is negative 9. If I plug a 3 here in, I get negative 3. Negative 3 squared is positive 9. So it actually makes a difference in your answer as to whether or not it is in parentheses. And so you have to pay attention to where your parentheses are, or if they even have it. They give it to you in this note over here. Negative 3 squared does not equal negative 3 squared. Looks like it would. It doesn't. Most common mistake made, like, ever, probably all the way until people die here, is this when it comes to order of operations, okay? How that negative is applied. Okay, so they want us to evaluate negative x squared minus 2 times x plus 1, 4x equals 3. So we're just going to plug a 3 in here. Negative. There is no parentheses, so we're going to say 3 squared. If you need to put parentheses like this so you remember, go ahead. Okay, but you do not apply the negative first. All right, and then we have minus 2 times 3 plus 1. So we could do, so in order of operations, technically you're supposed to do that parentheses first. You can actually do these at the same time because there's a subtraction in between them, and so it won't affect what you do. But if you do it strictly in order, we're going to do our parentheses first. And we do that 3 plus 1 there. And then we apply this guy right here. 3 squared is 9, and then we apply the negative. So we have negative 9. And then we can do this multiplication. 2 times 4 is 8. Negative 9 minus 8 is negative 17. Okay? So think of it as this. Basically a negative is just negative 1 times 3 squared is basically what that is. So when you see something like this, that's what that is. And so that's why you do the exponent first and then the negative, because technically that negative is a negative 1 in front of it. When you plug in a -3 into the C, it is in parentheses because the -3 is what you're plugging in. If there had been a negative on the outside of this variable, then you would have had a negative out here as well. But because you're filling in a negative, it goes within parentheses of that squaring. The entire number you're filling in is being squared. So the difference here and the difference here is this one did not have a negative on the outside. I plugged in my variable. -3 was the whole thing that I squared. Over here, the d squared had a negative here, which means I square the 5 first and then apply the negative, which kept it as a -25. The expression -0.3y plus 61 models the percent of eligible voters who voted in presidential elections from 1960 to 2000. In the expression, y represents the number of years since 1960. Find the approximate percentage of eligible voters who voted in 1988, okay? So they've told us what y represents, but they have not actually given us the literal y that we're going to fill in. What they said it represents here is that it represents the number of years since 1960. And they want us to find out approximately how many people voted in 1988, or the percentage of eligible voters. Okay? So from 60 to 88 is 28 years. So they have, in the word problem, told us the y value is 28. Okay? By defining the y value, they basically told us what to plug in. And so we're going to go back and we're just going to plug it in. -0.3 times 28, right? And then we're going to say plus 61, and that should be our answer. Now, you can use a calculator for this if you want to, but when you multiply that out, remember by decimals, you would just say 3 times 28, and then you would put a decimal in there, right? So if we did this, with our brains here, 3 times 8 is 24, hopefully. Yes. 3 times 2 is, plus 2 is, there we go. We have 1 decimal place, so that's going to be 1 decimal place in our answer. And so it looks something like this, right? Make sense? -8.4 plus 61. All right. And they rounded it to 53. So they rounded it to a whole here. All right, you get 52.6. So they just rounded it to 53. All right. So number 3, assume that the model in example 3 holds for future years. What percent of the eligible voters will vote in 2012, future, and in 2020? All right, so check your work. From 1960 to 2012 is 52 years, so you should have plugged in 52. From 1960 to 2020 is 60 years, so you should have plugged in a 60 there. And then the question is, give reasons why it would not hold. What are some reasons?
Combination changes.
So this next section deals with simplifying algebraic expressions. They start talking about terms. A term is a number, a variable, or the product of numbers and variables. The numerical factor in a term, or the number in front of the variable, is called the coefficient. The coefficient. And so they've given you examples over here. These are terms. 7x squared and 3y are terms. The coefficient here is 7, and the coefficient here is 3, right? And so you have variables and you have coefficients. And so there are going to be times when we ask for these things, and so you need to know what these mean as far as what a term is versus a variable and a coefficient. And then a constant is just a number that doesn't have the variable. Like terms have the same variable with the same exponent, right? And so if they are alike, then you can simplify them. If they are not, you cannot. And so they've given you 2 examples here. 3r squared, -1r squared. Those are like terms. The coefficients aren't the same. That doesn't matter. What matters is you have an r, and they're both to the second power. 2xy cubed and 3xy cubed. You have coefficients, which is fine. You have an x to the first power and a y to the third power. An x to the first power, a y to the third power, okay? So variables and exponents must be the same for them to be alike. And if they are, then you can simplify it. All right? So let's look at some properties here before we start doing it. Definition of subtraction. This has been since, you started adding and subtracting positive negative numbers. Subtraction is adding the opposite, okay? So a minus b is a plus a negative b. This helps when you have negatives butted up to each other or when you're just trying to decide, whether your answer is going to be positive or negative. Division is multiplication by the reciprocal, which is why you can't divide by 0. 0 doesn't have a reciprocal. Distributive property for subtraction works the same as addition. You just have a subtraction in between them. Multiplication by 0, we already talked about. Addition by 0, that's identity, but multiplication by 0, it's actually 0. Multiplication by -1, this makes the answer opposite of what it was originally. Opposite of a sum, here you are literally just distributing a -1. So -1 times A, -1 times B. Here, you'll notice they switched them. Why is that? Because -1 times A is negative A, and -1 times negative B is positive B. So what happens here is it actually switches them. Or you could write it negative A plus B. Same thing. This will help when we are factoring, though, this little key here. All right, opposite of a product. Some people tend to distribute a negative here. You only distribute if there's a plus or minus inside. If you have negative times A times B, it's only one negative there, not two, okay? Either negative A times B or A times negative B, but not both, okay? Some people try to distribute. This is not a distribution. And then if you have a negative times a negative, that ends up being positive, all right? Let's look at these examples. The first thing they want us to do is simplify. They literally just want us to add like terms. We have 3Ks, we're subtracting 1K. You can think of it as objects if you want to, okay? 3Ks minus 1K, you get 2Ks, right? So they factor it out and do like all these long steps. You can literally just add or subtract your your coefficients if they have the same exponent, okay? So it's K to the first power. You can literally say 3 minus 1 is 2. You have 2Ks left. All right, easy enough. B, my like terms. My like terms here are 5z squared and negative 8z squared. Notice I pulled that negative in front because that's what I'm going to use, okay? So 5 minus 8 is negative 3. And then my next set of like terms is negative 10z, positive 1z. Negative 10 plus 1 is negative 9z, and that is my answer. Just combining like terms here, okay? For the last one, we're going to distribute first, okay? If you can combine within your parentheses, do it. But if not, the only way to get it out of the parentheses is distribute what's in front. All right, so what's in front here is a -1. I'm going to take that -1 and I am going to distribute through to these. -1 times n is negative m. -1 times negative n is positive n. You can also flip-flop it if you want to, n minus n. All right, and all right, and then for the next one, I am going to distribute this 2. 2 times m, 2 times negative 3n. 2 times m is 2m. 2 times negative 3n is negative 6n. All right, so just distribute to get rid of those parentheses. All right, and then we're just going to add our like terms, just like we did on the one above it. We have a negative 1m and a positive 2m. Negative 1 and positive 2 is 1. And then we have a 1n. I'm disagreeing with what they have here. 1n and a negative 6n. All right. What do you have there? Negative 5. N. I don't know how. So last example here, example 5, find the perimeter. Obviously, they don't want you to find numeric answer here because that's impossible. They want to find it in terms of A and B. So what is perimeter first? What do we do to find perimeter? If this were all numbers, what would we do to them? We would add them all up. That's exactly what you're going to do here, okay? And so you're going to say 2A minus B over 2 plus, and I mean, they wrote it all out, but you know, B plus B plus B, right? So I've got this guy, right? Add this one up here. And then we have A plus 2A plus A here. So we really want to combine all of our B's. We're going to combine all of our A's, all right? Now, one way you can do this that makes it a little bit easier potentially is rewriting this as 1/2 times 2A minus B. Does everybody see why I can do that? Right? When you have a 2 on bottom, it's times 1/2. Yeah, it's just like A over 2 is 1/2 A, okay? And so if we look at these two like that, it actually simplifies it a good deal. Why? I'm not going to distribute here. What do you think I'm going to do?
The halves cancel out.
Right. They turn into a 1 is what they do. 1/2 plus 1/2 is 1, okay? So these added together gives you 1 times 2A minus B, which is much easier to deal with, right? All right, so I have a 1. You don't have to distribute a 1. If it were a -1, yes, I would have to distribute. But a 1 distributed, nothing changes. So those two turn into just 2A minus B. And I can literally add up all my A's and add up all my B's, right? When I do this, I have 2A plus A plus 2A plus A. So I'm going to add all of my A's. 2, 3, 4, 5, 6. So I've added all of those and I have 6 A's, right? And these I've already taken care of with this guy. I have a negative B, right? Plus B, that's 0. And then I have another B here, so that's 1, 2 B's. And so that would be how it looks simplified. 6A plus 2B. You literally just add them all up, okay? If there's a negative, it's a -1, right? I mean, that's all you're doing here. You're just adding and subtracting your like terms. So go ahead and try A here, 5A. Let's look at the first one. You can write it all out if you want to, or you can just go through it. 2x plus 3x plus 2x plus 3x. You should have gotten 10x. Then you have a -y, a positive y, a positive y, and a negative y. You should have gotten no y's, right? So your answer would have just been 10x, all right? Let's look at B, because this critical thinking is about B. The figure in part B is a rectangle with an indentation. By how much does the indentation increase the perimeter? So what they're saying is if the perimeter went straight across here, it would just have been D, right? Obviously. And we wouldn't have had these. So it increased it by 2D, increased the perimeter. Going in actually increases your perimeter. Because you add, like if you had to put a fence and you had to indentation in your fence, it would take more fencing. So they just wanted you